Equation practice. So, first of all, what type of equation is this? What happened? We got aluminum swapping places with sodium. So this is double displacement. So let's balance it. We have 2 aluminum here, because I want to do my metals first. 1 aluminum here, so I need to put a 2 in front. Then I have sodium. I have 1 sodium on this side, 2 sodiums on this side, so I need a 2 over here. And then I'm going to balance my polyatomics as a unit. So I have 3 sulfites here and just 1 sulfite here, so I need to put a 3 right here. Well, that changed my sodium. Now I have 6 sodium, so I need to go back and put a 6 here. Okay, then now I have, see how this is a polyatomic, OH, so I have 6 OHs, and over here I have 2 times 3, 6 OHs. So if I want to make myself feel good, I can go put a 1 right there. You don't have to, it doesn't matter. Okay, so I've got aluminum oxide plus iron gives me, what the heck is this? I don't know what this is. This is weird. This should be iron oxide. I don't know what that was. Okay, so I've got 1 element swapping places. So this is single displacement. So I want to do my metals first. I have 2 aluminum here, 2 aluminum here. Well, 1, so now I need 2. I have 1 iron here, 2 iron here, so I need 2 over here. 3 oxygen, 3 oxygen. So I'm all set. If I want, I can go back and fill in with 1s, but you don't have to. Okay, here I've got this compound breaking down into lots of little compounds. So that's decomposition. I'm just going to write DEC. Okay, I want to balance my metals first. So I have 1 sodium here, 2 here, so I'm going to put a 2 in front. Then I'm going to do my carbon. I have 2 carbons here, 1, 2 carbons total on this side, so that's okay. Then I'm going to do my hydrogens. I have 2 hydrogens here, 2 hydrogens here, so that's alright. I have 6 oxygens here. I have 3 here, 1 here, and 2 here. So that's 6. Oh, so then it's good. So if you want to go back and put in 1s, you can. Alright, so here I've got, what's happening? I have part of water. Now you can write water this way and maybe it will help y'all see this better. Do you see how my OH here is swapping places with my carbon? So that is double displacement. That one was a little tricky to see. But you can write water like HOH, and sometimes that will help you see things. Okay, so I still want to do my metals first. So I have 2 beryllium. I need 2 beryllium here, because this 2 only goes to what's in the parentheses. It doesn't carry over to the beryllium. Then I want to do my carbons. 1 carbon, 1 carbon, so I'm okay. I've got 2 hydrogen here. I've got 4 hydrogen here, 4 here. So I have a total of 8 hydrogen on this side, so I need 8 hydrogen over here. Then oxygen. I have 4 oxygen here, and now I've got 4 oxygen here. So we're balanced. If I want to go back and fill in with 1s, I can. Okay. This is some sort of alkane, carbon-hydrogen compound, plus oxygen gas, giving me carbon dioxide and water. So this is combustion. So I'm going to do my carbons first. I have 3 carbons here. I need 3 here. I have 8 hydrogen. I need 8 hydrogen here. I have 2 oxygen. I've got 6 and 4 is 10. So something times 2 has to get me 10. It's 5. Then if I want to go back and put in a 1, I can. Alright. Aluminum sulfate reacts with calcium hydroxide to produce aluminum hydroxide and calcium sulfate. So I'm going to have to write these now. Aluminum sulfate. Oh, I didn't really leave myself enough space to write my coefficients if I need to. aluminum sulfate reacts with calcium hydroxide to produce aluminum hydroxide and calcium sulfate. If y'all can't write these compounds, you gotta come in for tutorials and I'll show y'all how to crisscross again. Okay, so I'm gonna do my metals first. I have 2 aluminum here, I need 2 aluminum here. 1 calcium, so that's okay. And then I'm gonna balance my polyatomics as a unit. I have, oops, this should be 3. I have 3 sulfates here, so I need 3 sulfates over here, so I'm gonna put a 3. Well, that changed my calcium, so I need 3 calcium over here. Alright, then I've got my hydroxides. I have 2 hydroxides, nope, I've got 6 hydroxides over here and 6 here, so I'm good. I can fill in with a 1 if I need to. So what type of reaction is this? My aluminum switched place with my calcium. So this is a double replacement or displacement. I call it replacement sometimes. Don't freak out when I do that. Ethane and oxygen react to yield carbon dioxide and water. So I have ethane plus oxygen. Now remember, oxygen is a diatomic, so I can't just write O. I have to write O2. Any of the diatomics, you have to write the O2, H2, Cl2. You have to know those. Okay, carbon dioxide and water. Okay, so let me get rid of this arrow. I have 2 carbons here. I need 2 carbons over here. I have 6 hydrogen. I need 6 hydrogen. So I need a 3 there. Then I've got 2 oxygen here. I've got 4 plus 3 is 7. So I can't multiply anything by 2 that will get me 7 except for 3.5. I can't have half a mole. So I need to go back and double all my coefficients. So this will become a 2. This will become a 7. This will become a 4. This will become a 6. And this is a combustion reaction. Alright, aluminum oxide decomposes to produce aluminum and oxygen gas. So aluminum oxide decomposes to produce aluminum and oxygen gas. And remember, anytime sometimes it will say specifically oxygen gas, and then you know you got to put a 2, but sometimes like up here it won't, and you just have to know your diatomics. So this kind of tells you in the problem, it's decomposing, so this is a decomposition problem. So I've got 2 aluminum here, I need 2 here. I have 3 oxygen here. Oh, I need 3 here. This isn't going to work. So I could put a 3 here, but then I need 6 over here. So I need a 2 here, which changes my aluminum. So I need 4 here. Okay. Oops. Alright, that's it for this slide. 5th period, you will get a walk of shame. If y'all still need help, then you need to